Let's look at two more probability problems where to compute probability we have the choice of using order or ignoring order. So problem 1. Let's say we have an urn which contains 6 white balls and 5 blue balls. Let's choose 3. And ask what is the probability that we get 1 white and 2 blue. So here's my urn with the 6 white balls and 5 blue balls in there. We're going to choose 3 and ask what's the probability we get 1 white and 2 blue. So not exactly like this. I got 2 white and 1 blue. What's the probability we get 1 white and 2 blue? So we can't look at this as a single experiment repeated 3 times. This is not a single experiment repeated 3 times. Let me say this is not the same experiment repeated 3 times. We can look at it 2 ways. So we can look at it as a single experiment where we take 3 balls out at the same time. And if we do that, then we're ignoring order. Or we can look at it as 3 experiments that we do in succession, but they'd be 3 different experiments. Because if we take 1 ball out and then take another ball out, the second ball is coming out of an urn that has fewer marbles in it than the first one. And then the third ball is coming out of an urn that has still fewer marbles. So each time it's going to be a slightly different experiment. So if we look at it that way, here we're remembering order. Alright, so let's compute the probability both ways. So let's ignore order first. So we want to get 1 white out of the 6. So we have 6 choose 1 ways to get the 1 white, and then we want to get 2 blue out of the 5. So 5 choose 2. And the total number of ways to choose 3 balls is there's 11 balls total. We're choosing 3. So 11 choose 3. This is the unordered way. Then let's do it in the ordered way. Alright, so we could choose let's say the white ball first and then the two blue afterward. Or we could choose blue, white, blue, or we could choose blue, blue, white. In this case, there's 6 ways to choose the white ball, and then there's 5 blue balls. 5 ways to choose the blue ball, and then only 4 ways to choose the next blue ball, because of course we've removed one when we take out the first blue ball. And actually, wherever we're choosing one white ball, that's always 6. Because there's 6 white balls, we're going to choose one and then not do anything else. Whenever there's 2 blue balls to be chosen, there's always 5 ways to choose the first one and 4 ways to choose the second one. So this is the total number of ways to choose the desired collection of balls. 1 white and 2 blue. And then we have to divide by the total number of ways to choose 3 balls in order. So there's 11 total, 11 ways to choose the first ball, 10 ways to choose the second, and then 9 to choose the third. Alright, it's not obvious that these two answers are the same, so let's do a little simplifying. Even though normally, I think I would express this one as 6 times 20 is 120. 3 times 120, maybe I'd write this way, over 11 times 10 times 9. Or I guess 990 wouldn't be too difficult to write out. Alright, so what is this? This is 6 times 5 choose 2 is 5 times 4 over 2, which is 20 over 2, which is 10. 11 choose 3, let's see, is 11 factorial divided by 8 factorial times 3 factorial, which is 60 times 8 factorial cancels most of the 11 factorial. 60 times 6, 3 factorial, 6 over 11 times 10 times 9. Alright, 10 and 60 cancel, giving us 6 on top, so 36 over 11 times 9. And then we can cancel 9 out of the 36 on the 9, and we get 4 over 11. Alright, down here, 3 times 120 out of divided by 11 times 10 times 9. Well, we can cancel a 0 here and cancel the 10. So 3 times 12 over 11 times 9. Cancel the 3 from the 9, and we get 12 over 11 times 3. The 12 over 3 is 4. So 4 times 11. So actually, we did get the answer both times. We did get the same answer both times. And remember, if we're ignoring order, we have to ignore order in the numerator and the denominator. If we're remembering order, we have to remember order in the numerator and the denominator. Alright, let's do another problem that's kind of similar and that we can look at it 2 different ways. Alright, let's say we have 20 people, and these 20 people are actually 10 married couples. Let's choose 5 people out of the 20. And then ask, what's the probability that none of these 5 people are married to each other? So the unordered point of view is the probability, of course, is going to be the probability of well, it's going to be the number of ways to get 5 people that are not married divided by the total number of ways to choose 5 people. So whatever it is, divided by 20, choose 5. That's the number of ways to choose 5 people out of the 20. Alright, so if we're going to get 5 people that are not married, there's 10 couples, so we can take at most 1 person from each couple. So I guess we'll choose 5 of the 10 couples to take 1 person from. So now that we've chosen 5 couples, for every couple we've got first person or second person. First person or second person. So we've got 2 choices for each couple. There's 5 couples. So 10 choose 5 ways to choose the 5 couples. 2 to the 5th ways to choose 1 person or the other from each couple. And then 20 over 5 is the way to choose 5 people total. And then if we do this the ordered version, well, the denominator, I guess, is going to be easy again. There's 20 choices for the first person, times 19, times 18, times 17, times 16. So we've chosen 5 people in. Now, how many ways are there to choose 5 people that are not married? Well, the first person is not going to cause a problem, so we just choose. There's 20 ways to choose the first person. And then for the second person, I guess we can choose anybody except for the partner of the first person. So there's 1 person we can't choose, 19 total, so 18 that we could choose for the second. Alright, and then we want to choose anybody except for the partner of this person and the partner of that person. So we've got 2 chosen, 2 partners put aside, and I guess there's only 16 people that could be chosen for the third. And then we want to choose anyone except for these 3 that we've taken out. There are 3 partners that we're going to put aside, so that's 6 people removed. And then there's 14 choices for the 4th person, and similarly 12 choices for the 5th person. Every time we choose a person, we take their partner out also, because we don't want to choose 2 partners. We want to have no 5 of which are, none of these 5 can be married to each other. Okay, so we have this expression and that expression. Again, they don't look the same immediately. Normally I wouldn't bother simplifying much more than this, but if we want to compare and see if they're the same, then we'll have to simplify. So in this ordered expression, the 20s obviously cancel, and the 18s cancel, and then the 16s cancel. So that leaves us with 14 times 12 over 19 times 17. And I think 19 and 17 are both prime, so it looks like we're not going to be able to cancel anything else. How about this expression? Well, we have 10 factorial over 5 factorial 5 factorial, and then divided by 20 factorial over 5 factorial 15 factorial times 2 to the 5th. So 1 5 factorial cancels another. 20 factorial and 15 factorial mostly cancel each other. We'll have 20 times 19 times 18 times 17 times 16 on the bottom. Then we can get rid of the 15 factorial. 10 factorial and 5 factorial sort of half cancel each other, so we've got 10 times 9 times 8 times 7 times 6, then the 5 factorial left cancels with that factorial, and then we have 2 to the 5th. 10 over 20 is 1/2. 9 over 18 is 1/2. 8 over 16 is 1/2. So these 3 2's cancel 3 of those 5's. Leaving us, cancel 3 of those 2's, leaving 2 2's left. And now we've got 7 times 6 times 2 times 2 over 19 times 17. Or 7 times 2 is 14, 6 times 2 is 12. So we have 14 times 12 over 19 times 17. So indeed they give us the same answer. And again, if we're going to use the unordered point of view, we have to make the numerator unordered and the denominator unordered. And if we're going to choose the ordered point of view, we have to make the numerator ordered and the denominator ordered. The end.